Hey Kay, welcome to the podcast.
Hey, it's
Uh,
always good to be here. I don't know.
yep, yeah. So I'm so happy that you agreed to do this, and I'm sure that we're going to be talking a lot. But before we go ahead, why don't you introduce yourself for the audience? Yep.
Yeah, so my name's Kay Lee. I'm the CEO and co-founder of Silogy. We're making an AI agent for design verification. So our agent, who we call Viv, and root causes the source of test regression failures using a combination of waveforms, logs, and the code itself. Yeah.
Sounds good. Yeah, I think I've had the opportunity to talk you through about Viv in the past also, and I'm sure that we'll be touching a lot about Silogy and the verification engineer the AI verification engineer which you guys are building. But before we get onto that, I wanted to talk through about your background. I think that you did your undergrad in mathematics from University of Chicago. Is that right?
That's right. Yeah. I had a very out of sample path here, and
Hmm.
towards design verification.
Yep.
Yeah, I mean, yeah, so like you said, I went to the University of Chicago. I studied math,
Mhm.
basically just all pure math. And originally the idea was to go to grad school, but then sort of towards the end of my time there, I think I physically just couldn't, my body was revolting against me, and
Oh
I
wow.
think in my heart of hearts, I knew I didn't want to go to grad school. So then,
I see.
I decided to join industry. And so this was around the time when Flash Boys came out, the Michael
Mhm.
Lewis book about high frequency trading, and I kind of got
Mhm.
the wrong message from it, because basically the plot is, there are all these evil HFTs out there that are trying to make money by going really fast and stuff. And I actually had a professor who talked about the so-called high frequency trading arms race. And
Mhm.
he was telling me that there are these companies that use hardware to trade, right? And I was
Right.
like, that sounds cool. So I went to a small trading firm after college. After I didn't even really take that many programming classes in college. I took functional programming, but
I
it was
see.
good because no one could test me on it. So so I interviewed, got this job out of college, and then I started doing some statistic stuff. Quickly realized that I was really bad at being a trader because I really didn't like losing money, which is not a good property to have, right?
Yep.
But I
Mhm.
preferred. I actually really enjoy software engineering, so I went to that, and then eventually started working on FPGAs
Wow.
at this trading firm in Chicago. And then later I moved to New York to join HRT, Hudson River Trading,
Mhm.
also doing FPGA work. Yeah,
Right.
did mostly design verification. Yeah.
Right. So that is very interesting case. So you don't come traditionally from a hardware
No.
background, I would say. Like you haven't studied electrical engineering in your school. Uh, and then you ended up being a hardware design verification engineer working for almost what 6 to 7 years at HRT, right?
Yeah.
So how
Well,
was
4.5 years at HRT, I think,
I see.
and
Okay.
yeah, and then a few years at my previous job. Yeah.
I see. Okay. Okay. So how was your transition into the hardware design and verification space? Was it like very difficult to ramp up and uh, uh, like how did you got along with all of the RTL design verification methodologies, different tool structures because they are widely different from the way the software world works, and especially the fact that you worked on functional programming.
That's
That's not
right.
something which we do here in hardware world. So how was your journey towards learning all of the different techniques over the years, I would assume?
Yeah, it was very ad hoc. So this is why I'm glad you're doing what you're doing, teaching the next generation of engineers. So I had to basically cobble together my own uh program of stuff to learn about, right? In terms of
Mhm.
um UVM, different simulators, all that kind of stuff. I really didn't use any UVM for most of my career, right?
I see.
Which is the standard in the industry, but I had to learn it anyways. There was
Mhm.
Verification Academy, some other places, and
Mhm.
a lot of it is still very much you just learn from the people around you. So it felt like kind of an apprenticeship. But I also think that just good software engineering practices also translate over to doing verification. Like you have to
I agree.
build using like reusable components. I mean, this is why like UVM exists, right? So
Yep. Yep.
yeah, and thinking strategically about how to like test like a component, like stuff like that, I think is like pretty generalizable. But yeah,
Mhm.
yeah, it was very ad hoc, but
Yeah.
it was a good time.
And were you able to figure out like the resources? I know that you mentioned Verification Academy, which is a great resource to learn
Mm-hmm.
about, anything related to verification, and the fact that it also offers some of the hands-on exercises that adds on to your learning and stuff like that. But otherwise, also there are a bunch of different concepts. I see people trying to learn a bit about RTL, a bit about how synthesis is done, a bit about
Mm-hmm.
timing constraints, and then there is like the entire CDC, RDC methodology, and all of that. So how
Yeah.
was that experience for you there? And like, did you ever get involved into writing RTL also, like for FPGA and stuff like that?
Yeah, I wrote a bit of RTL as well. Basically, the way I did a bunch of that, or like how I learned, was just like talking to my coworkers, right, who are all very smart, who had worked at like
Mhm.
AMD and IBM and like a ton of other places, like startups as well. So they had like tons of experience, so I could just like kind of ask them. If you're, my tip is like, if you're like a young person, just like find somebody who's like who will be nice to you and is willing to
Mhm.
tolerate your questions. And a lot of the people who I worked at with HRT were just like so interested in hardware that like they would just talk my ear off, and like like sometimes I would like I'd be like I got to go back to work or something like that.
Oh wow.
Yeah, but then they would be like, no, you have to understand this is how the ALU works or something like that. I'm like, I
Mhm.
was just trying to understand like something completely different, but like they really wanted,
Mhm.
like I think a lot of people also want to like teach. So I
Yeah.
think,
Yeah.
yeah,
I think I'm one of those people who just love teaching,
yeah,
and I also sometimes do spend like a lot of time giving the background story about a bug, and then telling why was it not hit earlier on, and why is it hit now, and how we're gonna fix it. And
yeah.
that sometimes I feel that I'm torturing the poor verification engineers with a bunch of redundant information. But yeah, that's how I think a lot of people here in the company are, or in the industry are. They just love teaching stuff and giving away like what they learned over the
Yeah,
years.
trading war stories, because like sometimes like there are like really subtle bugs or like really subtle behaviors
Mm,
that you can introduce. Like hardware is just like so much different from software in that regard.
right, right. Especially because of the fact there are like million things which are happening in parallel,
Yeah.
and things can go wrong at any place, at any time, at any given clock cycle,
Oh
and
yeah.
then you have to just go back and debug it. Yeah, so I actually remember that even for me, I come from like a electrical engineering background, but still for me, ramping up on all of the different techniques was quite challenging. I could
Hmm.
easily guess that I spent years just to get a good hang of how things work. Why are simulators written this way? Why do we write test benches this way? Why does this particular hierarchy exist? And then the entire RTL side of things. So it took me a good amount of years to learn, and try to understand a bit about that. And one thing which I really felt which was missing in the industry was the entire debug methodology also, because
Oh yeah.
up until in my as an undergrad, I had never actually opened waveforms and debugged it cycle by cycle. So was that something like you also found challenging and difficult? Because I think one of the reasons I'm asking this questions is a lot of verification engineers, they don't tend to pinpoint where the exact bug exists, but
Hmm.
because obviously it's slightly hard to debug that way.
Yeah.
And given that things could have happened 100 cycles back, which was the root cause of a particular bug. But yeah, so like, how was your experience learning through all of that and getting used to all of the different tools, simulators, and the way things work in the hardware industry?
Yeah, I mean, it took quite a while, and I feel like I'm still learning things. So, I
Mhm.
don't want to position myself as some sort of expert, but like, yeah, I mean, I had a lot of like great mentors and a lot of great coworkers that I like learn from and like see like best practices from their end.
Mhm.
Yeah, like I think that there's like so many different areas you can explore in terms of not just like, you know, verification, but also like the RTL, like why certain things are written in a certain way.
Right.
that it's easy to like kind of, I don't know, get sucked into, like a hole when like trying to figure all these things out, right? And I think it's important to
Yes.
have like know how to like ask good questions, be able to find like the answers and stuff like that. Um,
Hmm.
one thing that helped me was like we used Verilator, which is like an open source like simulator, though
Yep.
like a lot of people
Yep.
would uh,
Not call it like a traditional simulator, especially for the
that's
fact
right.
that it lacks like a four state machine, right? I mean, it does not have X's and things like that. So.
Yeah, yeah, it's cycle based.
Mhm.
It's not event based. It has like
Mm.
like a bunch of people will like launch into the comments about how it's not real or something like that. But like something like that, like where you can because it's open source, you can look into the internals. Like some of
Right.
that stuff is actually pretty interesting. Actually, just reading like the system Verilog spec and
Hmm.
trying to figure out like the like yeah the like the because it's supposed to be specified out there, even though like every company supports it slightly differently. Um,
Right.
yeah. I
Mhm.
don't know. It's like a huge field, right? And
I agree.
it's
Yeah,
very
and I
difficult, like
think
without good, yeah, like without good
yeah,
mentorship, I think, to figure it out.
I agree. I agree on that. And I think we've just talked about like the front end side of things, and there is the entire back end side where you have like completely different tools,
That's
completely
right.
different methodologies, and working on a lot of different things where you get like the placement uh, and clock tree synthesis and whatnot. So all of that is like another big I would say like another field in itself to learn and master about. So. Mhm.
Yeah, I mean that stuff's all dark magic to me still. So like
Right.
I think with like chips, because it's like arguably like the most complicated thing humans have ever created, right? You can really get
Right.
like yeah, you can really go deep on like how chips are made, and like there's always more stuff to learn. You know, yeah, like there's a
Yes.
lot of attention spent on like fabs and stuff, and I still have no idea like what goes on. Like, I
I,
don't know.
I I agree with you on that. So I also have no idea like how do they get the chip out and whatever. Like what are the different processes and the stuff like that.
Yeah,
But yeah,
yeah.
mhm. Yeah, it's vast and there's a bunch of different things which you can get yourself into, try to learn and become masters. But I think one thing which I would like to pinpoint at what you've said multiple times is that you need to get good mentors, like especially
Mhm.
when you're working in a company, so that you can help yourself grow and learn a lot more about things and how they are working. So yeah, that's a very good advice, and I think I also share like the same advice to a lot of people who are just entering into the industry, that try to find a good mentor or try to find some of your colleague who knows something well, and just sit, chat through it, or try to debug something all on yourself and figure out like, hey, okay, this was the root cause and this is why it failed in the first place and whatnot.
Yeah, I also think being humble and like asking questions is a good thing, because like at first,
Yes.
like you don't want to like, it's like you don't want to pretend, or you don't want to reveal yourself to be like some sort of faker or something like that. But
Mhm.
it's such a vast like topic that like I think people are just like willing to talk to you about it. Like there's no reason that, or there's no way
I agree.
that like, especially if you're like out of college or early in your career, that you'll know everything, because there's too much to know. Yeah.
I absolutely agree on that. And I think I also do that a lot with my mentor. I still have like a mentor after spending like so many years in the industry. And every day I'm learning something or the other about, how the architecture was done this way or why the RTL design is done this way. Why was this trade-off made over the other and stuff like that. So yeah,
Hmm.
that's a good point. I agree. So going forward, you did touch upon your time at HRT and Hudson River Trading. So do you
Hmm.
want to talk a bit more about that? Like, were you involved in just like the FPGA side of things, or like did you guys do ASICs as well? And what was like your main role there, or main your day to day activities there? Yeah.
Yeah, I'll try to talk about it in like stuff that's publicly available, because like like every now and then like someone tells me that there are rumors that someone's going to sue me or something like that, but
Oh
like I
wow.
don't think.
Okay.
Well, I don't think I think those are all like I think that's all bluster, but like
Sure.
yeah, like so at HRT I worked mostly on FPGAs, and then they started making ASICs for high frequency trading.
I see.
And I was working as like a design verification engineer. I mostly did like FPGA projects, though
Mhm.
like I helped out in like all sorts of stuff. for the first like many years. And then towards the end of my time there, I started working on like the chip, like the tool stack. So we use a lot of Verilator, a lot of CocoaDB. You know, a lot of the people who contribute to CocoaDB and Verilator work at
Mhm.
HRT. So that's, you know, that's not giving away anything. And yeah, like, you know, like we were working on the tool stack a lot just to make sure that we could keep up with like the amount of like tests that were being run and yeah, like making sure that they like went as like fast as possible and stuff. Yeah.
Right. That's very interesting. I think you're the first person with whom I've actually learned that you're using CocoaDB, or you were using CocoaDB at
Mhm.
HRT for verification. So how was that entire experience? And one thing which I've heard people say a lot, that it's very or painfully slow. Is
Yes.
that right? Okay. So do you want to talk a bit about that? Like, how
Yes.
was your experience working with CocoaDB? Yep.
I mean, that was basically the reason why I like switched over to like the software tool stack is like it was like pretty slow. I mean, like combined with like Verilator. So
Hmm.
yeah, I think for like smaller designs, it kind of works fine. So if you have like an FPGA, you know, that doesn't have like too much logic in it or something, like I think it works
Hmm.
pretty fine. And also the nice thing is that you can like parallelize it a lot, right? So you can run like tens of thousands of tests, and you know you don't
Right.
need to pay the license costs like all in parallel.
Hmm. Hmm.
I do think that like for like larger designs, like if you're going to like tape out an ASIC or something like that, like something that does something like non-trivial, then you're going to need a commercial simulator. And then we also like, you know, purchase commercial simulators licenses to use. So
Hmm.
um, yeah, I mean, like I think CocoaDB is actually a great project, and so is Verilator. I think that you know, like there are probably some limitations, but like you can probably do, you know, 90% of like you know your verification with these tools, like if you really try.
I,
Um,
I I agree on that, and I think that's the same tool set which I'm also using for QuickSilicon. Like
oh,
all of my
cool.
courses there, they are actually built on top of Verilator and CocoaDB as the test benches. So
Right.
I enjoyed it, and it was learning experience at first, but then once I got a good hang of it, I was able to write all sorts of fork joins and all of that in
Mhm.
Python, and using the CocoaDB way and stuff like that, which is very interesting. And since my designs were typically very small, so I did not face any slowness or stuff like that. But
Yeah.
I agree, for like a commercial project or an ASIC sort of a design, it'll be very slow and it'll be challenging. Having said that, like, did you guys use any of the existing methodology for CocoaDB? I know that there is PyUVM, or like, did you build your own stuff around it and to do things?
I mean, we kind of use a mix, right? So like we built some stuff internally, but like we also you know use like open source like libraries and stuff. So
Hmm.
I mean, one of the nice things about Python is that you can just like you know pip install like whatever you need. So like
Yeah.
you know I don't know like Scapy or something like that. If I needed a network pack, I could just like get it done like pretty quickly.
Mm.
And you know yeah.
Yeah, I think that's the biggest plus point there. That if you need anything which is related, which exists today, like let's say SHA SHA-256
Right.
encryption and stuff like that, you just have to import a library and it'll be done for you. That's how quickly it is. So it does help with the functional correctness side of things, but yeah, then there are the downsides of it being slow and stuff like that. So coming to that, was your work at HRT mostly for functional correctness, or like did you guys paid a lot of attention towards how fast the design was, or on the general PPA side of things too?
Oh, I mean, we paid a lot of attention to like how fast things were, right? Like the logic here is that like the faster you can be, like the more money you can make, right? So we're just, you know, like Sam Altman was like complaining about people like trying to shave off nanoseconds, and then how they should work at OpenAI. Like, you know, I just spent, you know, like I spent a lot of my career just like helping shave off nanoseconds off of like you know FPGA or ASIC or like whatever designs. If you can
Yeah,
shave off
yeah.
more than a few nanoseconds, like people will bite your hand off for that.
Oh wow.
Yeah.
Yeah, I
So
saw that tweet too. Yeah, yeah.
yeah, yeah. So
Mhm.
yeah, I mean, like I worked a lot on functional correctness as well, but like
I see.
you know, we would try all these like tricks, and like sometimes like the exchanges would also do things to like help you out, like
Mhm.
because they know that people are using FPGAs and ASICs, and you know, it's like good customer service for them, I guess. But yeah, we really cared about functional correctness because, like, you know, I've had bugs which have lost, you know, redacted amounts of money and like a very small
Oh
amount of
wow.
time, And so,
Wow.
yeah, it's like yeah, because like a lot of your trading goes through like this hardware, right? There's no software process
Mhm.
to like. I mean, there is one that like monitors it or something like that, but like fundamentally, the reason why you're so fast is that you can just get like data off like um, the wire. It goes through
Right.
the chip, and then the chip
Mhm.
sends the order without any software intervention in between, right?
Wow. I mean, that's scary, and that's, I think, very different to the way the traditional, any other RTL design or things are done, because the feedback loop there is generally years. That,
Yeah.
hey, you get the chip and then you try to boot it and boom, it doesn't work. But
Mhm.
here you can, you just push your code ahead, it compiles, gets synthesized on top of an FPGA,
Yeah.
and then you can see your orders going ahead, and you're making money or you're losing money. Wow. I mean, that's scary, and that's good in a way that you get the feedback very quickly.
Yeah, I mean that's why you need robust testing, right? It's like things
I
can go
agree.
wrong like pretty
Mhm.
quickly. You don't get months to just like try to tease out all the bugs. You just got to do it, constantly.
Yeah, that's really interesting and scary at the same time. So,
Well,
yep.
what's scary about it?
I mean, yeah, I'm losing millions of dollars. Isn't that scary?
Well, I didn't say millions. I said redacted, but like
I see. Mhm.
theoretically you could lose like millions of dollars.
Right.
Yeah, I mean, yeah. Um,
Yep.
I don't know, but you could also make like millions of dollars or something, right?
I agree. Yep, I agree on that. Sure. Cool. Yeah. So thank you about talking through like HRT and the high frequency trading side of things. Coming back to the company which you're building right now, Silogy. So like, do you want to talk a bit more about it? I know that you talked a bit in the introduction sector, but like, do you want to share some more details as to what's going on and what is the product which you're building?
Yeah, so my company Silogy is building an AI agent for design verification. So basically, it's an AI agent that'll like look at failing test regressions, right? And if a
Hmm.
test fails, it'll go through and look at like the log files that are output. Well, it'll rerun it first with like some additional debug information and also dumping out some waves, and then it'll read like the waveforms, the log files, and some other stuff like the code and whatever sources of truth you have. And then it'll like go through and like generate like a guess, like or a hypothesis as to like what the root cause of the bug is, right? It could be either in the RTL or it could be in like the test bench, where maybe there's like some sort of like fundamental mismatch or something, or or like the spec's ambiguous, or like there's something that like somebody needs to pay attention to, right?
Right.
Yeah, so it has like this like long chain of reasoning stuff that you can actually
Mhm.
inspect, and what it outputs is basically a hypothesis as to like what went wrong. If there's a git diff, it'll like that'll just like fix it like one shot. Then like it'll like output that, and it also outputs like the waves in like Surfer, so you can
I
like go and like check its work. Yeah, it's really cool stuff, and you can like it's really cool to be able to like see, hey, I looked at these signals, right, and then you see the
Mhm.
signals in Surfer where you can like click to add them or like whatever,
Right. Right.
and then you can like it's kind of like an intern, right, that's always working, right? So
Hmm.
maybe it doesn't get it right 100% of the time, but at least provides you like some useful information to help you along in your debugging process.
Yeah, that definitely sounds very interesting. And I'll just like to talk about the last guest which I had on the podcast, Karthik Hegre.
Mhm.
So he's also building a company in the same space called Chipstack. I don't know if
Mhm.
you have heard about it.
Yeah, yeah.
And yeah, they're also building the verification agents for yeah, I mean, for verification, and focusing more on formal and UVM side of things, and then slowly getting into RTL design as well. Uh, so it's interesting to see that a lot of companies are coming up in this space, and this is definitely something which is needed in the hardware design space. But yeah, I want to talk a bit more about the product which you are building. So you said that it goes ahead, looks into the waveforms, looks into
Mhm.
the logs, and then tries to reason about what was the cause of the failure. I'm assuming that it needs like a particular setup for it to know that, hey, this is the waveform which I need to look into, or these are the set of logs I should go and look into for this failure. How is that done? Because generally, if there is a
Mhm.
lengthy setup process involved, then it's unlikely that a lot of people would be uh, willing to try it out or stuff like that. So could you talk through that?
Yeah, I mean, there are two ways that you could do it. One of them is like you can just like point it at like some logs and some other stuff directly that
I
like
see.
that's output by like a process. Or the other thing is like we also have a test runner, so or a test orchestrator. So you have a regression that has like 100 tests, right? They're specified like this. Like you just put it in the YAML file, and then it'll
Mm-hmm.
know how to run those like 100 tests, and then it'll just like collect the artifacts from it like
I see.
automatically. Yeah.
I see. Okay. Yeah. So having it automated is, yeah, definitely a big plus point.
Yeah.
And
Well, I don't know if
is
you
the
remember, but like, or I don't know why anyone would remember, but like, so we were a YC company, and originally there was no AI involved at all. It was just like this like CI/CD portion of it,
I know.
which like like I remember a group partner kind of like gently nudging us to like see if AI could be useful, but I was like still like being a little bit you know
Mm-hmm.
uh trying to be like counterintuitive or something like that. But
Right.
that CI/CD portion actually formed the background of this like test runner thing. Um,
I see.
and you can
I
also like
see.
run it on like Git pushes and all that kind of stuff.
Mm-hmm. Yeah, which makes sense. And since you were building a CI/CD, based tool, it'll be able to run it on and get pushes and stuff like that. But it
I
is
think
great.
CI/CD is still like an underappreciated part of like the verification process. Everyone does it slightly differently, and no one really
I
likes
agree.
it. But like, that's for another
Yeah.
day.
Yeah, I agree on that. So, there have been, multiple times where I'll just push something in the, beginning of the day, and I'll log in back the next day, it is still there, but just because some CI/CD test failed.
Yeah.
And I'll just curse someone that, hey, why is it happening right now? I wanted this to go in yesterday. But yeah, anyway, like you said,
Mhm.
it's a topic for another day. Coming back to the Viv, tool. So, does it understand different formats of FSDB? I mean, the waveform files, like, or
Yeah.
is it just BCD right now, or it understands FSDB as well?
Yeah. We have like tools that are able to query like FSDB and like VCD. Like, yeah,
I see.
yeah,
Yeah, because generally FSDBs is the standard in the hardware design
that's
space.
right.
Yeah, no, I see.
Yeah.
So which is good that if you're able to get around that and query what is happening in an FSDB thing. So that's definitely helpful. And I slightly want to talk about how was this AI agent trained. So like
Mhm.
whatever you could share about like did you went to GitHub, got data from there, and then trained it, or like you had your own set of rules and test data for it to be trained upon. So
Yeah. So, like without getting like too into the details, like we have like a set of like private evals that we use, like whenever we're trying out like new models, right? So like there are new open
mhm,
source models. Oh, the other like big thing is that it's entirely on premise, right?
right.
So we don't like send anything to the cloud. So if a customer comes to us, we just like and they say, hey, we would like to use your tool. We say, great, like we'll go and we'll install it on your own data service because the chips industry is like very IP sensitive.
I
Um,
agree. Yep.
yeah, so like so that's like one promise we have. So we use a lot of open source models and we have private evals
Mhm.
like internally that we use in order to like kind of benchmark which ones are like working and which ones aren't. And then we'll kind of like toggle some things in order to try to like improve like the performance on them. Yeah. Yeah.
I see. Okay. Yeah, that's definitely helpful. So, I mean, which is actually good that you have your own set of benchmarks in order to train that. Because I assume that the data which is available on GitHub, it is not something which can be solely relied upon.
Yeah.
I have like a repository where I know that there are bugs hanging in there. So yeah, so definitely, that's good that you guys have put in the thought and got your methodology and the benchmarks right there. So if you were to use this tool, let's say if I were to use this tool tomorrow, so
Mhm.
what would I have to do in order to use that? Is it just like I'll click a button and it goes on the background, looks at that failing test, tries a particular fix, and then reruns it and sees if it passes? Is it that, and then just ask me that, hey, I made this change, is that okay for you? Is
Yeah,
that
yeah.
how it works?
Yeah, more or
Okay.
less. So like there's like
Mhm.
a web app, like a GUI that you can like go and inspect like the waveforms and like its output. Functionally, the way that you would run it is like there's a CLI tool, right? So that you just like
Mhm.
say run regression or run the single test or something, and then
Mhm.
it'll do all that like test orchestration and then running like Viv on top of it. like kind of behind the scenes, and I'll just give you a link so that you can see like the status of like this like job that you're running essentially.
Mhm.
Um, yeah, I mean, yeah, we should probably just like allow people to use like, we have like a sandbox environment that people can use like
Oh,
online.
nice. Mhm.
Yeah, which is like different from the on-premise product slightly, right?
Mhm.
But yeah, I mean, yeah, maybe I'll like release that like soon.
Sure, that'll be great. I'll put the link whenever you release it.
Yeah, yeah, for sure. That'd be awesome.
Right. Cool. Yeah. And getting back to one more thing, which I just wanted to ask, that you said that this is an on-premise tool, which a
Mhm.
customer comes and you'll install it on their compute machines and their
That's right.
servers. So, how would the tool integrate with their stack? Because they would have like a different stack. I know that I've worked with a bunch of different ways where you either use like a makefile in order to build, test, and run it. Then you
Yeah.
have Bazel-based systems and whatnot. So, is that some integration you also do, or that is something which is left to the customers? They'll have like an API way to get around it.
No, I mean, we help the customers with that. So,
Mhm.
like everyone has like a slightly different build system. So we try to just like figure out like a solution that works for them.
I
Like
see.
our test runner, the way that you specify things in the YAML file, like it kind of works like you could just like run bash commands. So if it's something
Mhm.
that's like formulated in that way, then we could do something there like pretty easily. But yeah, the goal is to make this like very easily integratable into like your like existing workflows. Yeah.
Yeah. I mean that definitely sounds great. So I know that I've had the demo with you a few months back, and I was really happy to see that. One
Mhm.
thing which was missing back then was the ability to chat to the agent. So I believe that that is also now integrated and available. Is that
That's right.
right?
Yeah. Yeah, you can now chat with the agent. So,
Mhm.
yeah, that's also like very helpful. Like sometimes like we've noticed that it doesn't get it right the first time, but like if you like load it up and you're like, hey, like what about the signal or like what about that, then it'll like actually go through and it'll find it eventually.
Sure.
Yeah, it's sort of like having an intern once again. Yeah.
Yeah, yeah, yeah. So I know that you mentioned that it's like having an intern working for you, but uh, is Wave able to make changes across all the different files? So what I'm trying to say is that is it able to suggest RTL change versus a test bin change versus a test case change in order to get the test to pass?
Yeah.
Is that
That's the idea. Yeah.
I see. Okay. So yeah, that's quite interesting. So because that's one of the things where a lot of people sometimes struggle to get it right, where they do not know that something is failing. They know that okay, this is why it is failing, but I don't know whether the fix should go into the test or
Mhm.
it should go into the RTL or the test bench itself. So yeah,
Yeah.
that's pretty interesting. And I wonder that how Viv would be able to do that. I assume that it'll need access to the documentation, microarchitectural details, and
Yeah.
all of
Yeah.
that in order to understand.
Yeah, like yeah, basically. Yeah, the implementation, any like specs or micro architectural details that you can
Mhm.
provide will help it. Again, it's like not something that's like perfect, right? Like but it'll basically just try to figure out if it's like a RTL issue, if it's a test bench issue, or if it's like it doesn't know and that it just needs to like have additional information.
Right.
Yeah. Yeah.
Which is great, yeah. And like, have you had the opportunity to test Wave in an actual project or in an actual ASIC-based project where you have like thousands of files and so many things happening at one cycle, test running for hours and hours, and then trying Wave on top of it? Like, did you have you tested it in that environment also?
Yeah, well, I'll say that we're in a very NDA loving industry, right? So,
Mhm.
we've tested on like a number of like pretty robust workflows, let's say, and
Sure.
as far as we can tell, it's like working it works pretty well. I think whenever things get like too large, like maybe it's not like the performance kind of drops off there, like
Mhm.
as like
Yep.
the length of like the task or any dimension grows too large, like it stops like being able to like work as efficiently.
Yep, yep. I mean that sounds good, and I'm sure that that's something which you would be working on to improve because I think that's how the industry is, right? There are tests which are running for days even and stuff
Yeah,
like that, right?
yeah,
So one. one other question is that, like, is it even something which can help with formal verification? I mean, I was sensing that, whatever we were
Mhm.
talking before was, simulation-based test benches, but is it
Mhm.
something which can work alongside with formal verification too?
I actually haven't tested on formal. I'll be
Mhm.
honest. Yeah. Sorry, I really don't know, but we should probably try adding some like formal tests or something to try to figure it out. But
Mhm.
I still think that like most of the industry does like UVM like style
I
simulation
agree.
test bench. So that's kind of where we're focusing on for the time being.
No, that sounds, yeah. I mean, that's a fair judgment that a lot of companies are still using UVM, and but I every now and then I see that a bunch of companies have smaller teams which are just focused on getting formal verification right,
Yeah,
because the upside is great that if you're able to get all of the corner cases early on in the design,
yeah,
that's
yeah.
definitely a big plus for the company. Cool.
Yeah, I mean, I'm a big fan of formal in general. It's just like not a direction that we've investigated so far. Yeah.
No, which makes sense. Yeah, I mean, focusing on one thing and getting it right, that should be the yeah, that should be the way to go. It. So what's your north star for Silogy? Like, what's that one main goal which you guys are trying to optimize for, and that what's the one big thing that you want to get it out from Silogy?
Well, I just want to make design verification engineers' lives better. I think like there's not been a lot of attention paid to the humble design verification engineer. So like productivity hasn't really kept up. It's like still kind of like a niche field. I think that it's maybe underappreciated, but I think as we're starting to see like more and more problems that are like coming up from verification that like
Right.
I think it'll become much more important in the future. And so I would like to make people's lives better in that sense. That's kind of like the North Star. The way we do that like could take many forms. Like I think just cleaning up all of like the small bugs that like if you like spend like 30 minutes, you could probably figure it out. But it's distracting you from like the main work. Like maybe some of these like bigger tasks or like you gotta like debug like something like really intricate or something that like
Hmm.
LLMs can't do. I like to get that people like get that off people's plates, right? So yeah, I don't know. I would like to make verification engineers' lives better, I guess.
No, that's a great thought. I loved your line that you said that you want to make humble verification engineers happy with all of the
Oh
AI
yeah.
related products which you're introducing. Yeah, that's a great thought. Yeah, so I think that's pretty much what I wanted to discuss with you, Kay. But do you have like any last thoughts and anything which you would like to add, uh, and something to share about uh, people who are just entering into the industry, and yeah, anything which you would like to talk to?
Hmm. I guess like for people who are entering the industry to just be curious and to be interested, like know your tools, know what you're dealing with. There's like so much like space out there to learn, and also
Mhm.
be humble. Like I would encourage people to work on open source projects. I think there are a lot more out there now that are that can help you like upskill and learn a lot. I think chips are really cool. So that's my
I
advice.
agree on that. Yep, that's a great advice, and I think on top of that, find great mentors because that's the way to
Oh
grow
yeah,
in the
yeah.
industry. Yep.
No, this is the mentorship chat. Like, you should all find somebody to learn from and who's willing to teach. So yeah.
Yep, I definitely agree on that. Yeah. So yeah, thanks a lot, Kay, for taking out time and talking about your background, your time at HRT, and now that you're building Sylogy. I wish you all the best, and I do hope to use your product soon. Yeah,
Yeah, yeah.
and yeah, wishing you all the success.
All
Yeah,
right. All right.
thank you
Thank
for
you.
being here. Yeah, thank you.